Hello everyone. In this session, we want to solve the maze, and the goal is this robot here. We want to move it in order to robot get from this point to this goal that should be this flag. This robot could be anywhere in this maze, and also its face could be in any direction. So for solving that, first I define some few helper functions. First, the turn right that wherever the direction of the face of the robot is, we turn this face toward right. Turn face to right is basically is like we because we don't know at the beginning where is the face of the robot is, in which direction the face of the robot is. We need to and we have this function already defined for us. So if you go here the actually the keyboard, you see there is a function here. It says, or there is a condition here. So it says, is the face of the robot is toward up, toward the north or not? If it is toward north, it returns true. So I want to use this condition in order to have in order to define these four functions to change the direction of the robot toward that direction we want. For example, here it says turn the face of the robot toward right. And remember, because we don't know which direction is the robot face at the beginning, so we need to actually turn left. We while through the left, we looping through the left, and we do this loop as many as time that we reach the face of the robot toward up. And then with that happen, we just can simply turn right. So, and we are sure that if we go through this turn right after the face of the robot is toward north, then we are sure that this robot face is toward right actually. And we can do the same similar thing to make sure the robot face is toward up. Same for left. We turn as many as this iteration to make sure the robot face is toward up. And when that happens, we just simply can say turn left, which by going through these lines, we make sure that after this, the robot face is always toward left. And same for down. Now, we want to use this maze function that we developed, which actually accept four parameters here, which at the beginning, these four are false. And this four parameter says the previous move uh, was in which direction? Was it toward right? Was it toward left or up or down? The previous move. And whenever we reach at the goal, we know that it's done. We don't need to do any further. Basically, this is the base case. If you know about the recursion functions, you know that we need to have a base case. And this is our base case. If you don't know about recursion, I have plenty videos that prepared in that topic that we can watch those. So and here I have four section. If the previous move wasn't left, then do what? Turn the face of the robot toward right. And if the front is clear, it means that the face of the robot is toward right. And we know that the front of the robot in toward right way is clear. So what we do, we move and we say, okay, now that we move toward right, call this maze again. And we know that we right now, we move toward right. So that's why I only change this right toward true. Same for down. If the previous move wasn't down, then you're allowed to turn up. Why is it that these are in opposite direction? So here, if I say the previous move wasn't left, then you're allowed to turn right. And the same for down. I'm saying if the previous move wasn't down, then you're allowed to move up. Same for right. If the previous move was not right, then you're allowed to turn left. And if the previous move was not up, then you're allowed to turn down and move toward down. The reason is if you don't do this, then we could end up to an infinite loop. Imagine that the robot is moving toward right, and then you give the robot this option to also come back again and one step toward left. So this robot could stuck in the like infinite loop. It goes left and then goes right, goes left, goes right, and you're stuck there. So in order to that never happen, so I just saying if, for example, you already move toward up, there is no reason for you come back down again, unless this is not quite 100% accurate what I said here, because there is chances that you go up and the front is blocked, so you need to come back down. But with this code, we already took care of that as well. So let me run this now, and we'll see how this run, and then we go more into detail later. So robot starts here. Now it goes left, goes up. There we go. We end up at the position that the goal was, but just for the sake of to show you it will run in other position, let's rerun it. Now the robot is here. So if I run this again, there we go. We end up at the end. Just want to make it more clear here. This is very in depth in basically recursive programming. So there is, as I said, there are other like series of videos in recursion. So I couldn't get into more detail of why we did this, and but uh, in recursion, because we don't know where is this robot starts at the beginning, so the robot need to go different path, and whenever we reach to the end it just stops there. That's why here we go and also visit here. Maybe from you guys say, okay, why the robot comes this path and come back again, because we don't know where is the robot starts. Could start anywhere, right? So the robot needs to be need to explore all the options to see where it is ending up. And just one thing, if you change the order of these, if you change the order of these functions, definitely the way that the robots move could change as well. This is also another point that I guess you guys need to check my other videos in order to understand why I'm saying that. Why changing order could end up robot, you know, traversing different direction. But still, if you change the order of this, the robot obviously will end up in the, you know, at the goal, but it could traverse different path. Well, that's it for today. If you have any comment or question, please leave it down below. Otherwise, stay tuned for the next sessions. Have a great day.